Hello everyone, and welcome to the 12th Shelly External webinar. I'm very excited for today's session as this is our second partner-led webinar. We are joined today by Kaloyan, the CEO of KalaTech and very trusted partner of Shelly for many years. He has joined the Shelly streaming room to walk us through using Shelly e-meter devices over ModBus communication protocol, specifically in solar systems and manufacturing. And now I would like to invite you to use the chat throughout the entire session to add your questions, because at the end we will open a Q&A section where we will answer all of your questions together with Kaloyan. So I'm just going to step aside now and let Kaloyan take over. Thank you very much for joining once again. See you in a bit.
Hello from my side. Nice to see you all, and thank you for being here. Thank you, Shelly, for the invitation. I'm always happy to share with my colleagues and other people interested in automation, what we do and how we do it. So in KalaTech, we are system integrator of automation, like industrial, home, building, data centers, any kind of automation, mainly focused in energy efficiency and also robotics and other stuff. So I'm also a CTO of AIoTCloud, which is a cloud-based solution for energy management and data analytics. In all our projects in the last, I would say, more than 15 years, we have been dealing with types of automation that are both existing upgrades of old equipment and old buildings and so on. So we are also partnering with Siemens, Schneider Electric, ABB, Wago and other big companies. And today I want to share with you actually how few of our specific project types look like, and actually why and how Shelly is helping to the whole concept. The things that we're going to discuss together today is like two topics, but they're pretty closely tied together, as you will see. The first one is unlocking the solar connection and potential with Shelly, and then how to make one step further and connect to SCADA systems. So the first topic will be more related about the solar, where we are, as you know, solar is a big boom now. We have batteries, we have investments, we have very strict development in all, like government, like manufacturing. Everything is very hardly pushed towards integration and manufacturing solar. And one of the key topics is how to use the solar actually more beneficial and how to make the most of the investment. So making the most means that you should control. Controlling is usually made after you measure what is the consumption, what is the production. Integration of batteries is also a crucial part. So here actually Shelly is the device of our choice. In a minute you'll see why. And we're going to show you a connection between a Shelly device and SunGrow data logger. It is more or less the same with many of the rest of the other loggers on the market. On the second part, you see how, using the same approach, we are going to connect the same Shelly actually to a SCADA system and Power Metering Expert. This is the name of the system. It is by Schneider Electric, and this is the solution of Schneider for energy management and monitoring, including water, air, gas, and any other type of medium. I'll speak a little bit about the specifics of what we are going to do today. In the first part, we are going to have a hands-on on integration of Shelly EM Pro, which is in this case a 50 amps Pro device, Pro power meter, and we'll show all the steps how to check the data, actually what is ModBus, why we use it, and so on. Before we step to the actual hands-on exercise, I want to tell you actually why the ModBus is the protocol of choice here, and there may be two parts of this question. First, all the projects that we tend to execute are, as I mentioned, either upgrade of old buildings or integration of new devices in new buildings, new machines, new facilities. On the new part, we use almost 99% of the time MQTT protocol. If you're not familiar with this is kind of a message queue text protocol, which is closely related to sending short commands or short messages between many devices, and it's very useful in bad connection states if you're using mobile, if you have thousands of devices and so on. So again, this is our protocol of choice. If not, as you will see later, most of the data loggers don't support MQTT. Most of the industrial devices still don't support MQTT. Most of building devices also. So when this is the case, our second best option is the ModBus. ModBus was invented in 1980, something like this, 1979, by Modicon, which was later acquired by Schneider Electric. And since then, you can imagine all of the equipment of Schneider Electric is ModBus based, plus many other devices, because it became quickly the protocol of choice in the 80s, 90s, 2000s, and up to today. The initial version of ModBus was actually serial based, meaning that it is a serial connection over RS485. And the benefit of this actually is that the total length of the cable could be about 1 kilometer. And the minus of this architecture is that you have daisy chain, meaning you have several devices connected with one cable going to a gateway, or the device that is going to read the data. Again, the plus side, the long distance, the minus side is the speed and the limitation of the number of devices and the need of a gateway. About the year of 2000, ModBus, maybe 1995, something like this, ModBus was updated with ModBus TCP, which is actually the modern version, and it is using TCP connection, meaning routers, switches, Wi-Fi access points, any type of modern medium. Here, on the minus side, is that the length contracts regarding the TCP requirements, meaning about 100 meters or something like this without a repeater. On the plus side, it's pretty easy to connect many devices to one central location and network. Just for the record about the MQTT, it's not also a very new protocol. It was invented close to 2000s, something like this, 1999. But until 2010 to 2013, it was held by other companies, and then IBM made it like a public open source, and since then it boomed in the IoT industry. So both of these protocols are not like 5 years old. They have pretty good coverage, pretty good testing, and so on, and are the most used protocols in the world nowadays. Additionally, you may be familiar with Profinet, Profibus, which is Siemens communication, and some other proprietary protocols. Nowadays, everything is going open, and so open protocols like MQTT, ModBus, and others, which are openly available, and I will just show you in a minute how you can find why they are open and how to get the data. They're pretty much preferred because you're not vendor locked to one vendor. This is actually one of the cases that we show here. We use Schneider, we use Shelly, we use Sungrow, so the protocol is pretty much universal. Just to show you in a picture how the things will be connected today, we will have some ModBus devices, then we have gateway or no gateway, and then we will connect the data to the solar data logger, and we will achieve some readings there, and we are going to be able to slowly and steadily control the solar inverter. So not only on-off with a relay, but also slow and steady control. How does it work and what we are going to do today? I'm going to show you on our desk here. We are having on our demo board one Shelly device, which is Shelly EM Pro. We are also having a Sungrow logger, and we have a Shelly switch, which is connecting all of these data. So here's the switch, this is the ABB gateway, and this is the Shelly, all connected via Ethernet cables to the switch. Here we have the SunGrow, which is data logger. Again, could be Huawei, could be any other make that supports ModBus TCP. If not, either ModBus Serial or via gateway, it's also a viable option. All the things connected to the 5-port Shelly switch, and on the side we have my laptop. The things that we are going to do step by step now is configuring the Shelly for communication via ModBus, and adding the Shelly to the SunGrow, and a little bit explanation about addressing and mapping registers, because if you didn't see ModBus up to now, you see it has some tweaks that you need to know. So going to the demo itself, we have loaded here the web page of our Shelly, and this is again Pro 3 EM, which is 50 amps, one single phase. You'll see in a minute why this is important in the case. This is the home menu, and we have like 2, maybe 3 options that we need to check here. First, we need to go to the, in this case, LAN connection, and set up static IP address. This is pretty helpful, because when you need to find the device in the network, it is much easier. Having the static IP is kind of enough here, and after we connect to the network, it is a pretty good idea to go a little bit lower to the firmware section and update to the latest version. For now, as of today, it is 1.7.0, so it is pretty recommended, so you can use the latest features and have less headaches with the new communication. So the last step here is going again to the settings, to the ModBus, and you need to click enable and save the settings. This is usually, it is by default, this is enabled. Also, if you need to check, it is a good idea to check. Here you can see that the port 502, this is the default port for ModBus communication, like in 99.99% of the cases. So if you want to use ModBus communication over TCP, this is what the port that you need to open on the routers, and etc. So kind of easy first step, as I told you, that's why we use Shelly. And the second step is going to the data logger. Data logger, we need to log in, It is in the same network. We are using the default password, and we are greeted with the initial setup wizard. Here, usually, we add the inverters and we add power meters. So in our small room, we don't have space for solar inverters, but we have the logger and the meters. So we are manually add the Shelly device. So we are clicking add device. We go to meter, because this is power meter, and we select where it will be put. One case is here, electricity meter, the other one is a gateway meter. The difference in this case with SunGrow is that if you want to limit the production, this is the place to put it as a gateway, because this is between the utility and your home or facility or manufacturing and so on. Here you could have batteries and other stuff, it could be here. So if we want to see this meter in the menu for limitation and power control, this is the gateway meter. It's not crucial, but you can change it later, but it's easier when done from the first time. Which port this is connected? As I told you, ModBus is available on serial ports like COM1, 2, 3, and also in this device on the net port, which is Ethernet port, which is ModBus TCP. So here we see ModBus TCP, here we see the IP of the Shelly, or if you don't see it, you can put it manually. And we see the port. You remember, all the ports are available, but this is the one that is the default. About device model, unfortunately Shelly doesn't exist here. Here you can see like this one, this is Schneider, this is some other companies and so on. So many of these, they have they're called drivers, which are more or less a list of numbers, as you see in a minute, but this is others, and configuration method, we can import file if we have it, if not, we are going to do it custom. So now we click next, and we are presented with the table with 33 parameters, which are phase voltages, currents, powers, whatever. So all of these could be useful depending on what we are going to do. And as I told you, the device that we're currently using is single phase. So obviously we will not have three-phase voltage, we will not have many of the things here. So it's possible for us to just click here and remove all the parameters and just set up the ones that we need. Here we go to the interesting part with the devices and the ModBus registers. You can see the ModBus, here it's called ModBus ID, it's actually a register, and it's 3000, 3001, some code here, like a register type, 0x3, this is function code, I will just explain in a minute what they mean, and data type, integer or float. How to know what to put here, actually, Shelly knows, so you go to the web page of Shelly, in the knowledge base, and you find the device Shelly Pro EM. Or 50 EM. So here, when you scroll to the bottom of the page, you see components and APIs for this device and other devices. So especially we need this device. What we have for this device, we have system, Wi-Fi, Ethernet, cloud, MQTT, and ModBus. So here we go to the ModBus. And here we see all the methods that are supported by this device. And a little bit below, we have EM data, EM1 data, switch, and input. What is the difference? EM is the real-time values, currents, voltages, powers, and so on. Here you can see phase A, phase B, phase C, and so on. So this is for the three-phase unit. EM1 is for the one-phase unit. So this is what we are going to use now. EM data here is the historical data. The watt hours and like active reactive energy, produced energy, and so on. So when you see it in MQTT communication, again, EM data means historical, EM means real-time data. Going to the EM1, we see some addresses here, and we see, for example, voltage. This is 32003. So for this one, this is float type, meaning floating point, and it is in voltage. Theoretically, we take this value from here, we go here, and we say, okay, we enable this phase A voltage, and we put the address here. We choose float, because this is the type, and we can check it by reading back. And we don't see anything. So this is very common in ModBus, as I told you. So here we have several reasons for this. ModBus is related to function codes which start with 0, 4, and 0, 3. Behind these codes, here comes the confusion. Behind these codes comes address space, meaning a list of addresses. So function code 04 means input registers, but the space for the input registers starts with a 3, and 03 here means holding registers, and the address space starts with a 4. So whoever did this had a sense of humor, but you know, this is exactly the opposite of what is written here. So 04 is input registers, which is okay, and since we have the address space starting with 3, because we already checked this function code, we don't need in this case the leading number here. So we try to read again, and we see some number here on the right, which is obviously not the voltage. So this is the second fun part about ModBus, that sometimes this is 0 based and sometimes this is 1 based. What does it mean? It means that some companies count from 1 to 2003 or 2004, others count from 0 to 2003. So here, in this case, they count from 1, so 2003 means 2004. We will show you in the end a document that you can check it and see it by yourself. Also, just in a minute, I'm going to show you a tool how to check all of this. You don't have to remember it. It's just two fun facts. First about the address space, and then about the 0 or 1 based. Knowing these two facts, I think you can handle many ModBus errors. So reading back this time, hopefully, we see this is 234 volts. So in this case, by checking just one of the registers, we are sure that we need when checking this technical document, we need to take away the 3 in the beginning and to add 1 in the end. So this is very helpful because it is not a very pleasant moment when you put here like 30 registers to check it and to check them and to see that they don't work. So this is how this is done. I will not put all the registers here because we're kind of short on the time on this presentation. We can put some other one just to check how it goes. For example, we can take, I don't know, active power, which is here, 32007. We copy paste just to find active power, total active power. This is here. Again, we put it. We remove the 3 in the beginning because it is part of the function code, this one. And its input register and add 1 here, 2008. And again, it is a float. Again, we go to read just to check, to be sure. And we see 0 because this is actually a 0 because we don't have any consumption or production. So this is the way. When we finish adding all the registers that we need, we go confirm, and actually we can close this page. And then, just in a second, we can see our device here in the device list, which is with communication status connected. Here, this is the green thing here. And if you want to change something, we can go to the settings and change. And if we need to change the address, we can go here and also edit. So this is the main idea. And in the overview page, we can see the device statuses of the inverters. And now, actually, we don't have any kilowatts, so we don't see the numbers. But after adding the devices, you can see them here. Here on the device monitor, you can see the real-time data of whatever we have added. So just as an addition to this, I want to share with you one tool, which is called ModScan. This is the tool. This is the one actually that I've been using and many of our colleagues are using. It has a free version. This is a licensed version. It is time limited, so you can use it also whenever you decide. To check our assumptions about the ModBus registers. Usually, how it goes, you go to the connection and you put the IP address here of the Shelly. You remember the port 502. This is mandatory, and we click OK. Then we are connected and we see here ModBus exception, which means that the connection is valid, but the device is giving us errors. Why it is an error? So this is because we have coils, input registers, holding registers, and input again. So these numbers is the function code. 04 is input. If you pay attention here on the bottom, below the ModBus, the red font of ModBus, you see that if I choose input, this is starting with a 3 on the beginning. If I choose holding, this is starting with a 4. And then here on the top is my address. So if you want to test our assumption about the address, we go again here. We see, for example, from 32000 to 3218, we have like 18 addresses here. We can go back to this tool. We can say just to 2000. And we need to have input registers. And we need to read, for example, 10 of them. In many of the cases, it is possible to use the whole address or just the last part. And in many devices, if you move one ahead, you can see the data, as you see here. If we put 2000, we see the exception and we see no data. If we put 2001, as you remember, this is 0-based, 1-based. This is what we see, and why this is like this, because we expect to see here floating points. We can check integers just to see that we have some numbers. So this is a valid ModBus reading. As you saw, just moving the first address one left or right, this is making the whole like 10 addresses invalid. Because some of the devices, when they have invalid request, the whole response is invalid. So this is kind of another tricky part. So meaning when you have one exception, doesn't mean that nothing is working. It means that maybe you should move one left or right. So this is the final ModBus trick that I'm going to show you today. And again, using this, we can also test inputs and outputs. So one of the things I want to show you here is that, for example, if you go again on this website, we can check, just a second, we can check the switch. The switch is kind of simple. This is a coil. The address is 100. So going back to my favorite software, we go to a coil, we go to 100, and we need just one address. We see the exception, but we know that we should move one to the right, and we see a 0. This is actually the status of the output of the relay of the Shelly. And here, if I double click, I can select on. And when I click update, you can see here on the test bench, the light goes on. If I click again, we're just showing how to control via ModBus a Shelly device. And I will just click it again. Yes, on means the light is on, and off, this light is off. So this is pretty nice tool for use when you have ModBus troubles. And believe me, you will, if you don't know these tricks that we just shared. Going back to what we did and why we did it, these are part of the benefits that you can use by using, you can see by using this approach. First, of course, enhanced monitoring about the production and ability to control is the crucial part. As I mentioned in the beginning, if you have invested like a few million euro in a solar park, it is pretty good idea to measure how effective this park is. If you have also need of batteries and some other equipment, it's pretty easy when you have the data from the Shelly device to be able to take informed decisions. Sometimes the Shelly device itself is not enough. The Shelly cloud is kind of made for Shellys, and this is actually we are going to the second part of this webinar, where we will show some third-party system which can take all of these data and show you a view of this. But still, utilizing ModBus is pretty important. About the fault detection, if you have a faulty inverter or faulty data logger or something like this, having a Shelly device is pretty crucial for you to have a second opinion on what is happening with the whole system. So you always have another pair of eyes. You have another device which is taking data, sending data, not connected directly to the rest of the system. So it is kind of a bulletproof solution for data loss, connection loss, device fails, and so on. About the part of this I mentioned in the beginning, this is optimization of the energy and the ability to control. As you saw, you can control also the relays with this, and the compliance regarding bigger solar parks, they kind of need mandatory by the law to be able to send some data and to be controlled. So this is pretty crucial. And again, multi-site monitoring becomes kind of easy, because no matter if you have like Huawei, Sungrow, Solis, Groat, whatever inverters and data loggers, you can still use additional Shelly device for taking the data to the central system and possibly control. In the second part, we will speak about the SCADA, and you see that all the things that we just saw and all the ModBus tips and tricks and all the things that we already know, it's kind of pretty easy to be applied in any type of SCADA. The devices, again, here, the same things apply since the beginning, that devices usually support many types of protocols. Some of them are open, some of them are not. And again, in our projects, many types of devices need to be controlled. Some companies have 10, 15, 20-year-old equipment. Some companies just built a new factory, but they have old administration, or vice versa. We have big offices. Now co-working spaces are like pretty normal. People renting spaces, they want to have the central data in a big system that is taking the data from all facilities. One of them has Schneider automation, the other has Siemens, the other has Shelly, the other has any other type of equipment. So they need one source of truth, which is the big SCADA or the big monitoring system, which is controlling and taking data from all the rest. Nowadays, bigger companies like Schneider, Siemens, ABB, and the others, they have their own solutions. Almost any of them could be applied in the case that we are going to show today. Why we use Schneider? Because it's kind of cheaper option. This power monitoring software is one of the softwares that we have like the most of our energy management projects, not especially needing control. We are just using this, and it is kind of pretty popular all over the world because of this. It is again open, as I mentioned. One of the minus sides of this special software of Schneider is that it doesn't support MQTT and some other better protocols, but ModBus is good enough in the case. Again, we use Shelly with the ModBus. Just a few words about the SCADA, because we had this question asked a lot. SCADA is not one SCADA, meaning like somebody is making a SCADA and you can buy it. So SCADA actually is an acronym. It means supervisory control and data acquisition. Supervisory and control means you look at the things and you control them, and data acquisition is you take the data, you monitor, and you have history. So one of the key parts of any automation system is to have the history and to have the data log. And nowadays, you're familiar with not only ChatGPT, any type of machine learning tool or data analytics tool could be used. So all of these data make sense. We have many of our customers that we make like a full digitalization and digital transformation roadmap of the facility. And it turns out they have some Excel, some SQL database, something that they get data the last 10 years, so 5 years, and they have manual Excel macros or some Power BI tools or something that is taking the data. And actually they cannot make informed decision even though they already have the data. So the data acquisition is not only saving the data in Excel or anywhere, it is analyzing the data. So the SCADA systems that we tend to use take the data, store the data, analyze, and then control. All of these could be achieved by many building blocks. You can use one SCADA like for a central location, many small SCADAs for like remote offices or solar parks or manufacturing facilities. And the small SCADA could talk to the big SCADA. So this is could be different vendors, could be different devices, and so on. What we do actually in most of the cases is that we choose several vendors which are compatible between each other, again because of the open protocols like MQTT and ModBus, and we make system architecture case by case using simple building blocks. Well, again, what we are going to do today, we have mentioned here the industrial gateway of ABB, the SU200, as you're going to see in a minute, but this is one of the good gateways on the market that have local data monitoring and local data visualization. It is kind of nice to look at. It has many options to connect with different devices, and this is kind of the local gateway for many of the projects that we did. If the connection to the cloud or to the main server disappears, this is one of a very good local solution to have the data. Today we are not going to pay attention exactly to how it's done. It is like 99% the same what we did with the SunGrow. We log into the page, we add the registers, and we start collecting the data. The more interesting part is the second part where we see how the Schneider Electric software is looking and how to configure the devices again. Here it can be easier than before because we already know the ModBus tips and tricks, and I'm just going to go towards the session where I will show you the software. This is the global demo of Schneider Electric Power Monitoring Expert. It is also available as a trial, so you can contact us to get some information about licensing, about demo, about proof of concept, and so on. It is divided in dashboards, diagrams, trends, alarms, reports, so it's kind of pretty rich software. Most of the companies that want to license in ISO 50001 or some other energy efficiency certifications or CO2 emissions or whatever, it's kind of off-the-shelf solution which already complies with all of these certifications. Here, this is the global demo again. This is global acceptable. The user and password are demo and demo, so we can send it additionally, or you can just use it as it is. So I will go a little bit through some of the options. You can see here you can make dashboards. These dashboards could be visible on phones, tablets, big TVs. You can make a slideshow. All of these are like pretty much drag and drop. So this is for example, heat maps, pictures, whatever you can put here. This is kind of easy to use software, and this part with the dashboards is easy to use for the end customer. The next part about the diagrams, I will just show you some that are already prepared. Today we will not have the time to do all of them, but I will just show you how some of them look like. This is kind of a device level diagram. We can have equipment level diagram or higher level. Just a second. For example, in buildings segment, we can see this type of map. This is more or less drawn case by case, and this is not like pre-made for the customer. The first dashboard, it was drag and drop things. Here you need programming skills and the software to do it. The trends are real-time data that you can check. This is especially useful when you check some functions, when you add new devices, just to see how it works. And I will not go to the alarms, but we have many types of reports, which, for example, energy management reports, you can go to the calendar report, you can see load profiles, you can download in Excel, in PDF, and whatever. So all of these, like cost reports and stuff like this is kind of an invoice. So all of this is available out of the box. I will just skip to the local machine that we have locally. Just a second. This is a virtual computer that is running Schneider Electric software. So you can see that it's pretty easy to test locally. And the installation is about 2.5 gigabytes, something like this. It could be run in the cloud, it could be run on a local machine. It consists of several sub-softwares. Each of them is responsible for setup of devices, of logic, of visualizations, and so on. Today we're going just to show you the one about the visualizations. Which, just a second, I'll show you this. These are the software packages that come with the software: designer, graphics editor, license, management console, Vista, which is the visualization, and the application itself. We're going to go first. The thing that we saw just on the demo is the web application, and we're just going to the management console so you can see how we can connect the Shelly to this system. We start the management console, we log in with the supervisor user, which is the admin here. And we see the server name, the server itself, the sites, which means gateways. As we spoke during the presentation here, we don't need a gateway since we have a Shelly. Again, if we have Siemens, Schneider, whatever other types of non-TCP devices, if you use ModBus serial, they need to go to the gateway, which is serial to ModBus TCP. Then here you can click new gateway, new Ethernet site or gateway site, and you put the IP address here. So this is one of the places. You put a name, you put the IP address, and of course you know about the port 502. Here you can select it. In this case, we don't have the gateway, don't have the need of the gateway. You have devices, again, new device. This is Ethernet device. If we have the gateway, we say this is a serial device on gateway Ethernet site. In this case, this is a directly connected Ethernet device. The group is Shelly or floor 1 or whatever. The name could be administration. And device type, we should choose the device type. As you saw in the SunGrow data logger, Shelly is not available in the beginning. So on this step, we need to go one step back and we need to create the device. I'll just create one or two variables just to show you what is the similarity and what is the difference between what we did in the beginning. This is the device type editor that we are starting here, and this is a new device template. As you can see on the left side, it's like thousands of possibilities what could be measured, and here we have the ModBus table. If you remember, we go to the ModBus table again, we see again the voltage, for example. And unlike what we did with the SunGrow here, because you know Schneider invented the ModBus, they use the ModBus as it is. So here the 4 in the beginning means holding register, and then the address is 1234. So here we have the possibility to directly copy and paste 32003. So In some very rare cases, you need to put another 3 in the beginning. It is I've seen it in some manufacturers that even though we have it in the address, it needs to be added again here just for having the function code in front of the address code. Just have this in mind. In this case, it should work like this with Shelly. Again, we should check if it's again 0 based or 1 based. So this is the thing that we used ModScan in the last demo. And we say that this will be float, for example, which is IE float, this one. So now one of the specifics here is that we should put, for example, voltage. This is the name. And one of the specifics is the Young handle, which is a specificity of Schneider. And all the things you see here on the left side, these are kind of Young handles. You can go and you can find, for example, the voltage. We see some voltage, for example, this one, average voltage or phase voltage, or which one you choose, and you just drag and drop this here to the handle. And in this way, you already have a template. How to add additional row? Here you can right click and insert, or you can go on the bottom. So you add additional row, you add additional numbers and ModBus registers and so on. So this is the idea. Before saving, because if you save it like this, all of this you can imagine as a folder, which you're going to see in the software. So having one voltage here and saving it as is, you're going to see all of these folders with all of these measurements, and it's pretty hard to find the data afterwards. And this is why it's a good idea to go here and to clean the measurement tree. So this is tools, clean measurement tree, which means that it will delete anything that we are not using here. And we have the voltage here. So in this case, this is the power meter. This is kind of mandatory field to have. And we have only one folder with voltage inside. Saving this file save us, for example, Shelly EM50. And then we have install device type. This is installing the device into the drop-down menu that we already have. Here, if we have a diagram, we can put it here. This is the, if you remember, the part that you need, the software itself and kind of a few little programming skills and knowledge how to draw the diagram. This is optional. Then we have the device name. It could be Shelly EM Pro 50, for example. And here you see ModBus and Ethernet support, because this is the ModBus TCP. And we install. We see that this is installed successfully here on the bottom. And we can go back. So having made all of this and going back to creating the new device, sometimes it takes some time for the things to show up. In the device type, we have a search bar here. So we can just put Shelly, and you see here in the list, you see the Shelly Pro 50. So this is how, for example, now we're going to put IP. Just 1 second. We use the group that we created before, if we did. If not, we can put a new one. And we need the name administration. So we click OK. And we can see the device appearing here. Just to refresh. Yeah, in a minute it will appear here, device connected, and we are going to take the data. So I'm not going to show you, because just to draw a line in this software especially, we need 3 points. The default data acquisition period is about 15 minutes, so about 45 minutes will pass before we are able to use all the functionalities. So I'm not going to show you all of this. I can just show you very fast how we can see real-time data and how the Vista looks like, the visualization tool. actually this is the startup screen, which is kind of sad, like a very gray color. So we say we make a new diagram, which means a new web page. If you're familiar with web design, kind of this is what it looks like. It is kind of what you see, what you get. On the bottom you see the toolbox, and you can drag and drop. For example, this is a number. And if you want to put something here, you right click, you choose link, and you go to custom link. And if you remember the Shelly administration, this is what we created as a group. And in a minute here, we're going to see our Shelly with the data. So this is how you create all of the visualization. Here you can put pictures. This one can look like, if you go to the display, it could look like a number, like this arrow, like a partial display, full display, horizontal bar. So this is how, piece by piece, you make the web page. You change the background, white for example, and this is how you make page by page the whole design. And again, for this, it's kind of more engineering, and it is very specific for Schneider software. But after preparing all of this, we achieve like the system similar to what I showed you here on the demo. Okay, going back to our presentation. Why actually we did what we did? Because the energy monitoring is kind of important. One of the things that we mentioned about is that the complexity and many devices that we already have, many different manufacturers and so on, we need a common protocol and a common software to take the data. Again, the plus of Shelly is the ModBus. The plus of Schneider is that it's kind of cheap as this type of software, and this is also open to ModBus. And then we have the integration with any other type of medium and other type of software. We have the efficiency, we have the automation availability, like you saw lighting the lights with industrial controllers, with Shelly devices, with all kinds of devices could be entered in this software. We have also the protocol flexibility, and we also have like the scalable solution. So again, for all of the things that you saw here, we can support you and KalaTech and AIoTCloud. If you have questions on all of these topics, or you need additional information, I understand the ModBus is not like the easiest to explain protocol, but we can help you here. And we prepared one document before going to the Q&A session. This will be available in the knowledge base pretty soon. This is kind of all of what we explained, summarized in one document. Where to go for the Shelly ModBus and how the address looks like. This is a simple explanation why this is 3 in the beginning, why we add 1 in the end, and the stuff that we did with all the data, and all the things that we did with the Schneider software, but with the full driver already installed, and with all the data already in the system. So with this, I want to finish this part of the session, and again, thank you all for being here, and thank you, Chennai. Now we're going to the Q&A. So
perfect.
Yeah.
Thank you very much for the demo and in-depth explanation how to work with these systems and the communication protocol. Okay, let's step into the question portion in just a second. And the very first question was about the document. Are we preparing a document where we can follow all those steps that you mentioned? So you just answered the question here, I would say. Yeah, looking forward for the document very soon in our knowledge base in Shelly. Definitely we will announce the document in Facebook community as a post, so you can have it and go and read and set it up on your own if you need, of course. Let me just go to the chat and see what else as the communication is ongoing. That would be helpful. Okay. What is the license model for the Schneider software, and how that can be acquired?
The license model for the Schneider software is you should buy a license for the server itself, and you should buy additional device licenses for the number and type of devices that you use. This could be installed on cloud, could be locally. For now, as far as I know, it's only one-shot license. It's not month-by-month licensing. The server is kind of fixed, like it doesn't matter if you use 10 points, 10 devices or 100 devices, you have the server license fixed. And then, depending on the model of device, manufacturer, number of registers and so on, it is 3 types of licenses. So kind of one-shot licensing, and if you want to update later, you pay some part of the price for the update.
Perfect. What if I want to just install it for testing and learning?
It is available. We can send it. You can send some request to us. It's available also from Schneider, but it's kind of hard to find. The installation file, it's available. It has latest version. I am not sure that how big is the demo period of the trial, but the last version from 2023 or 2021, it's kind of more or less the same software. They have 90 days trial. So you can try with Schneider website. If not, we can send you the link.
Okay, perfect. From whom you could buy this? Just Schneider or resellers?
This is kind of solution software that the partners which could actually buy the software are licensed partners in energy management solutions. So you could probably find the license in any distributor which has license for energy management, but most probably you're going to need some help or someone to actually start up the system. Any system integrator of Schneider who has energy management batch, this is how they call it, they can sell you the license, they can start up the system for you, and they can help you, but still it is possible to find it in some distributor networks if you think you don't need the help to install it.
Okay. And Heinz is just saying, oh, 90 days, perfect for testing, thank you.
Yeah.
Do you have the specifications for the system it can run on?
This one is available on the Schneider website, in Google also. So this is it's called System Architecture Guide, I think, or IT Guide, depending on which part of the system you're most interested. So this is publicly available document on the Schneider website.
Okay, perfect. This was the last question. Feel free to add any other questions if you have. But yeah, other than that, thank you very much. It was great. It was a great session, and I received in a private chat the question where we can, and also in the chat in the webinar for the webinar, where we can see the recording afterwards. On Monday, we will upload the webinar from today and the webinar that we have tomorrow to Shelly Academy YouTube channel, so you can follow and subscribe, of course, for the channel, so you can watch all the videos that are upcoming now and the future ones. Okay, any other? Let me see. We don't have any other questions.
I hope you like the ModBus and you use it smart. And the tips and tricks that you saw are pretty useful for you. So yeah, again, if you need something, you can find us. You can Shelly or me. So we're going to leave our contacts, and yeah, if something appears, we'll be happy to help and to work together. Yeah,
now we will let a slide with contacts of Kaloyan for a couple of minutes as a slide, but we will now say just goodbye and let the slide stay for a bit, so you can take his contacts and reach out with any further questions. Okay, before we close, just a second, last question. In your experience, how easy it is to approach customers with existing Schneider hardware with new hardware such as Shelly?
Here it's kind of two-part questions. First, if the Schneider hardware has the gateway, because how smart it is. I suppose it's about Schneider Electric power meters, which are ModBus serial. So you need to have the gateway. Any gateway we do. No need to be especially Schneider. And it is serial to Ethernet. So you go to the ModBus TCP. For the extension part, it's kind of pretty easy to use the Shelly, because the Pro version, because they have also the ModBus TCP. And after you put everything to ModBus TCP, it depends on the type of the software that you need to install. So hopefully it also has ModBus TCP. It could be Schneider, it could be any other, could be Home Assistant if you want. Anything that is connecting and having drivers for ModBus TCP is good enough. Here the tricky part is to get the good gateway, which is translating the serial Schneider communication to whatever ModBus TCP or any other type of protocols the software and the other gateways are supporting.
Okay, perfect. Okay, that was the last one.
Yeah.
But if you have any other questions, now is the time.
Yeah.
Okay. Anyways, thank you very much, everyone. Thank you for being here, and yeah, see you on the next one.
Yeah. See you. Bye.
Bye.